Hello po, welcome po sa chapter ng Scheme Appraisal for Highway Projects. Today we're going to talk about the main types of methodologies in the assessment of desirability in economic and environmental or social aspect of constructing a highway proposal. So, economic appraisal of highway scheme, highway economic analysis, also known as project appraisal, involves quantification of the costs of and benefits from a scheme over a selective time horizon and evaluation by a common yardstick. The technique is also known as benefit cost analysis. So, highway project appraisal is often involves comparing various options. Using economic appraisal or some other decision analysis technique, it involves calculating the feasibility of the project before committing resources to it. It is that highway planner uses for choosing the best project that would help them to attain their goal. So, sa next slide tayo. Economic appraisal of highway scheme. The aim of the highway appraisal process is therefore to determine the economic, societal, and environmental feasibility of the project or group project under examination. The process enables highway planners to decide whether a project is desirable in absolute terms and also provide a means of choosing between different competing project options, all of which have the ability to meet the started goals and objectives of the project sponsor. So, why it is important to know the feasibility of the project? It is necessary to determine the economic, societal, and environmental feasibility of the project because knowing the economic feasibility is important to highway development. They can allow a highway development to address where and how it will operate. They can also identify potential obstacles that may impede its operating and recognize the amount of funding it will need to get the highway project up and running. Cost-benefit analysis or CBA. A cost-benefit analysis (CBA) is the process used to measure the benefits of a decision or taking action minus the costs associated with taking that action. A CBA involves measurable financial metrics such as revenue earned or cost saved as a result of the decision to pursue a project. So, cost-benefit is as simple as dividing the benefit by the cost to calculate the benefit to cost ratio. Sample natin ay mayroong kitang 1,795 over 1,000. So, ang equals nun is 1.795. You can use the cost-benefit analysis to test a particular alternatives or compare several alternatives. Kung ano yung pinakamas mataas na benefit cost ratio, siya yung pinaka choose natin. Again, cost-benefit analysis or CBA. CBA is a process used to determine the value of a project in relative terms. CBA is a consistent approach and methodology that can be applied to all road projects, thus enabling projects or project elements to be compared. Nag-conduct tayo ng CBA or cost-benefit analysis if mag-pursue tayo ng project or mag-assess tayo ng value ng project. If pwede din namang mag-i-compare natin yung mga option na available na Bale, hanggang dito po muna yung ating video kasi sineparate po namin yung ibang topic sa ibang video. Yung ating pong link ay nasa baba, nasa description. So,
good day everyone! So today I will discuss my topic and I will start with environmental appraisal and highway scheme. Environmental appraisal of highway schemes. Cost-benefit framework for a highway project addresses the twin objectives of transport, which is the efficiency and safety, but it makes no attempt to value its effects on the environment. So we all know that in every engineering project, there is always impact on the environment. The excavation, the cutting of trees, increased noise, air pollution, reducing habitat for animals, and many more. So in order to lessen the impact on the construction process, assessment should be done. This kind of assessment began in United States in 1960 when environmental issues gained in importance. The structure developed within the last 30 years and it is called Environmental Impact Assessment or EIA. Environmental assessment within the project planning process is needed in every engineering project. The process was made statutory under the National Environmental Policy Act of 1969, which requires the preparation of an environmental impact statement for any environmentally significant project undertaken by the federal government. So in every engineering project, kailangan natin ng environmental assessment before ma-approve ang iyong project. So NEPA prescribes a format for EIS requiring the developer to assess the following. 1. The probable environmental impact of the proposal. 2. Any unavoidable environmental impacts. 3. Alternative options to the proposal. 4. Short-run and long-run effects of the proposal and any relationship between the two. And the last, any irreversible commitment of resources necessitated by the proposal. This list aids the identification and evaluation of all impacts relevant to the evaluation of the project concerned. But why there is a need of an environmental assessment? So here is the objective. A central objective of this program was to put in place a mechanism for ensuring that the effects on the environment of development projects such as major highway schemes would be taken into account at the earliest possible stages within their planning process. Minimum information that must be contained within the EIS are 1. A physical description of the project. 2. A description of measures envisaged to reduce or remedy the significant adverse environmental effects of the project. 3. The data required to vote, identify, and assess the main effects on environment of the project in question. The design manual for roads and bridges has provided the format of the environmental assessment of highway. It identified 12 environmental impacts to the assessed of any new or improved trunk road proposal together with the economic assessment. So what are these 12 environmental impacts? So the 12 environmental impacts forming the assessment frameworks are: Number 1, air quality. Vehicle pollutants such as carbon monoxide, oxides of nitrogen and hydrocarbons, lead, carbon dioxide, and particulates are being assessed. Established models are used to predict future levels of these pollutants, and the values obtained are compared with current air quality levels. In this way, we can assess the impact of the project in air quality on the place. 2. Cultural heritage. Under this, it is assessed if the project will disrupt or affect any cultural heritage site. 3. Construction disturbance. Under this, the nuisance such as dirt, dust, increased levels of noise and vibration created by the process of construction are assessed if it affects the viability of the project. 4. Ecology or nature conservation. The highway being proposed may negatively affect certain wildlife species and their environment or habitats along the road corridor in question. Habitats may be lost, animals killed, and flora or fauna may be adversely affected by vehicle emissions. Number 5. Landscape effects. The local landscape may be fundamentally altered by the construction of the proposed highway if the alignment is not sufficiently integrated with the character of the local terrain. Other environmental impacts are the land use, traffic noise and vibration, pedestrian, cyclist, and community effects, vehicle travelers, water quality and drainage, geology and soils, and policies and plans. It is important that environmental information is presented in as readily understandable a format as possible. One such format provided for in DMRB is the Environmental Impact Table, or EIT. DMRB advises that an EIT be constructed for all relevant appraisal groups such as local people and their communities, travelers, and the cultural and national environment. Here is an example of an environmental impact table. As a summary, an environmental assessment is very crucial in every construction project in order to assess the impacts of it in the environment. We can assess it by using the assessment framework through the 12 environmental impacts. And an environmental impact table (EIT) is a good way to show the impacts relevant to each of these appraisal groups. The basic elements of traffic analysis. We all know that the functional or the effectiveness of an highway is measured in terms of its ability to assist and accommodate the flow of vehicles with both safety and efficiency. But in order to do that, in order to measure its level of effectiveness, certain parameters associated with the highway must be measured and analyzed. So here are the following parameters: the quantity of traffic, the type of vehicles within the traffic stream, the distribution of flow over a period of time, usually it is 24 hours, the average speed of the traffic stream, and the density of the traffic flow. Analysis of these parameters will directly influence the scale and layout of the proposed highway, together with the type and quantity of materials used in this construction. This process of examination is termed traffic analysis, and the sections below deal with the relationship between the parameters which lie at its basis. The speed, flow, and density upstream of traffic. The traffic flow, represented by Q, a measure of the volume of traffic on a highway, is defined as the number of vehicles N passing some given point on the highway in a given time interval T. In equational form, Q equals N over T, or the traffic flow equals the number of vehicles over the time interval. In general terms, Q is expressed in vehicles per unit time. On other times, the number of vehicles in a given section of highway can be also computed in terms of the density or concentration of the traffic as follows. The equation is K equals N over L, where the traffic density, which is the K, is measured of the number of vehicles N occupying a length of a roadway L. For a given section of road containing vehicles per unit length, the average speed of the vehicles is termed the space mean speed U, or the average speed for all vehicles in a given space at a given distinct point in time. So if you want to know the average speed for all vehicles in a given space at a given discrete point in time, this is the expression, where L is the length of the road used for measuring the speed of the vehicle. It can be seen that if the expression for Q is divided by the expression for K, the expression for U is obtained. Thus, the three parameters U, K, and Q are directly related under stable traffic conditions. So Q equals UK. This constitutes the basic relationship between traffic flow, space mean speed, and density. So guys, this is just an introduction. So if you want to know more about the topics, this includes speed density relationship, flow density relationship, and the speed flow relationship. Click the link below. Determining the capacity of a highway. There are two differing approaches to determining the capacity of a highway. The first, which is predominant in the US and the other countries, it is called the level of service approach, and it involves establishing from the perspective of the road user the quality of service delivered by a highway at a given rate of vehicular flow per lane of traffic. The second approach, which is used in Britain, puts forward practical capacities for roads of various sizes and with carrying different types of traffic. Within this method, economic assessments are used to indicate the lower border of a flow range, the level of which a given road width is likely to be preferable to a narrower one. An upper limit is also arrived at using both economic and operational assessments. Together, these boundaries indicate the maximum flow that can be accommodated by a given carriageway with under given traffic condition.
Bale, yung level of service ay ina-describe niya yung experience ng mga driver dun sa highway or dun sa pag-travel nila dun sa highway. Factors na ina-consider nila is travel time, kung gaano kabagal or kabilis, kung matraffic, kung ano yung kung may obstruction ba sa daan, sa gilid ng daan. kung may obstruction ba sa gilid ng daan, and many other things. Bali yan ay apag-usapan na lamang natin sa next video kasi paubos na yung oras. So, thank you all.